And yeah, so welcome everyone and everything like that. So I will be honest, this section, this part of like the module 2, I think there's so many different ways you can kind of talk about like statistics and the way you do inferential statistics. Um, and so I'm gonna kind of jump around a little bit from like maybe what, section 12 to section 13 to section 14. If you guys just give me a thumbs up, who here has gone through section 12, which we kind of talked about last week a little bit. All right, thumbs up, okay. How about, has anyone gone through, at least started section 13? Which is, I think was it sampling and central limit theorem? Am I getting that right? Okay. And then I think next is section 14. Is anyone in section 14? I know some people might be a little bit ahead. All right, no one's there. So that's going to be hypothesis testing. So one thing I kind of took out is if you guys remember last week on section 12, we talked about statistical distributions, went through a whole bunch of stuff. Remember the Gaussian, normal curve, bell curve. It goes by many names. It is the superhero of all statistics. You'll see this kind of go over and over again. But I kind of skipped over one part of it, which was the z-test. And I'm really kind of holding that off until maybe we'll get to parts of it today, probably not. That's okay, because we're going to talk about it in hypothesis testing, which will be, Thursday, so our next study group. And we'll kind of talk about z-tests, t-tests, hypothesis testing. What does it all mean? Why are we doing this kind of stuff? And so we'll see if we get to, I have confidence intervals kind of like at the end of this kind of session and everything like that. To be honest, I don't necessarily think we'll get to confidence intervals. Maybe we do. But even if we do, I think there's a lot more we could talk about, and we'll kind of tie that into our next study group and stuff like that. So that's kind of like, you'll see me kind of play a little bit with the sections these next couple weeks, just because there's so much crossover, and sometimes it makes, in my mind at least, it makes more sense to talk about them together versus like, saying this is section 14 and then like just talk about that versus like say, well, let's combine this together. Okay, pretty good. All right. So let's see here. I didn't see anyone put anything in the questions for the Google Sheets and stuff like that. So this is kind of something actually a little new than we've been doing before. We had questions for like office hours and everything, right? And one thing I kind of heard from feedback after the Mod 1 project, stuff like that's having more like time for questions and stuff that you guys can ask and stuff like that. I didn't see anyone really put anything
I
in there,
put
but
quite a few questions on it, I think.
okay, cool.
Did it
So
not?
maybe
But we
I
can
might have
leave
checked a
them
little bit later.
for next week or next time.
Yeah, here, we'll take a quick look because this might be actually something we talk about
I
too.
might put them in the wrong Google Doc. Sorry.
Oh no, you're in the right place. I see him now. I think, you know what, I might have looked at it previously. It's been a busy day today. So I might have missed more. I might have looked at the wrong doc. Okay, cool. Thank you, Nadine, for mentioning that. So cool. So this is the Google Sheet right now. Just gonna close these guys if you don't need them up. So just kind of quick questions. And this is where I think I'm gonna try to put this in available for you guys so you guys can kind of add in questions and stuff as you go through, and you can see we can answer them or spend some extra time answering those questions. It always helps if you guys put like lessons and stuff, like what lesson number from Learn. So let's check out, let's hear section 13. Oh, good, thank you for putting the sections too. So 13, to get a sample, is there a difference between or better option between NP random choice or df.sample? That's actually a really good point. I actually believe those are this, I could be wrong. I believe they're actually using the same mechanism. So remember data, pandas actually uses NumPy underneath it. I think, I could be wrong, but I think they actually use the same like mechanism. So there's different names of the same thing. Kind of like when we do like Seaborn and like Matplotlib, a lot of times Seaborn is actually calling stuff from Matplotlib. Or if we do like, or data frame.hist. But good question. I don't quote me on that, but we can always check out the documentation in a second. Let's see here. How does bins auto work in plot.hist? Oh yeah, so I sort of understand what's going on, but not exactly. So I will tell you, this is where it's kind of confusing because if you guys do plot.histogram, right, and then you have to define your bins versus the auto bins, it's doing, I honestly have to look it up every single time because it's doing it between a min and max and then splitting up in a certain way. Usually my suggestion is if you're just doing something to just quickly look at it, just let bins be auto like the default, which is what kind of goes through down that part. and let it just, so you can explore it really quickly, right? So again, explorations are quick and dirty visualizations. You don't care if they look pretty. You don't care if they're all smudged and you're like, have to dig a little bit deeper. But if you're doing for explanatory, right? If you're showing this to a stakeholder, another data scientist, you might want to work your visualization a little bit more. And that makes when you actually, I wouldn't suggest putting auto for bins on that. I'd probably say specifically what are the bins in there. So kind of good thing to note. Honestly, I always forget exactly how it works because it always go like, if you aren't careful, you're like, wait a second, like that's not the right number of bins that I thought it would be. So it's always good to kind of double check that. But for exploratory stuff, you're just like, just throw it in there and see what comes out. And then if you need to kind of dive in a little closer, you can kind of adjust the bins to something more manual. Okay, cool. And stop me guys if you guys have any questions. I'm just kind of firing this right through so we can get right to it. How does this line of code work? How are the things extracted from plot.hist? Count bins ignored. Okay, this is actually a really good point. So I think this is the code right here as being mentioned. Is like count bins ignored, all commas, equals plot.hist, and then S is, I'm assuming, like the data. Bins equals bin size, so there's probably some variables saying what the bin size is supposed to be, and then density equals true. So I think these are the three things. So this right here is actually a really cool part of Python, is that this is actually right here, this plot is returning, this plot.hist is actually returning a tuple. So a good thing to kind of check this out is plot is matplotlib, right? So we can just do matplotlib, and then what was it, hist, right? Let's just do hist and pull up the actual documentation. And I always try to go through the documentation versus Stack Overflow and stuff like that, just to get a feel for this stuff. Not that there's anything wrong with Stack Overflow or other question stuff. We can see there's the inputs and stuff, a whole bunch of stuff, because it's matplotlib. You can do whatever you want pretty much with it. But the thing I'm looking for is returns. And you see returns here. It actually returns 3 different things. You can see here, it goes n, or 4 different things. Or, no, 3, I'm right. N, which is the list of arrays. It talks about what those are, which are the different bins. Bins, the edges of the bins, and then patches, a list of lists. So this is where it's really good to, like, if you're like, hey, what is this function doing? Or like, you see someone else's code, you're like, how did this happen? It's good to kind of check out the documentation and see what exactly it is. Of course, you can always do that within Jupyter Notebook too. But I like to look it up online since, we have the internet, and then I can always explore more. So one thing to know is that it's returning 3 different things. So what's kind of cool with Python is you can return, this is actually returned as a tuple. So remember tuple, even though it sounds like 2 things, it can be basically anything within that parentheses with commas separated, right? So you can have a tuple of 3 different things, 4 different things, 2 different things. You can even have a tuple of 1 thing, but that's kind of redundant. But the point is that you can say, okay, all of this together is 1 thing. So for example, if I go back to that code that was shown, if I instead had put something like, let's just say C equals this, that would actually, that C would be the whole tuple set, which would be N, I can't remember what the other parts are, N, bins, and patches. So those are the different parts, right? You can also, Python does something kind of like pattern matching, where with tuples specifically, it'll actually try to say, hey, there's 3 different things, and you are matching with 3 different variables. So it'll actually make count, bins, ignored, 2 different things. Or sorry, 3 different things, and that's each part of the tuple. Note if you try doing this with like count, bins, ignored, Python's gonna get really upset at you, and it's gonna say, hey, like it's too many variables to unpack. And basically it's saying, hey, there's 3 things here, but there's 2 things you gave me. I only can do everything or individual parts. I can't figure out what thing you want. So note that sometimes that happens. You probably have seen this already, like in curriculum and other code. Usually the code looks something like fig, ax, ax, right? And then like, plot dot like subplots. Okay, this is a very common thing that you would do. And basically it's just returning 2 parts. If I instead, this can happen sometimes, you just return fig and you try doing your normal code, you might find things don't work the way you expect it. And it's because you actually have a tuple of 2 things. You actually have the fig and the axis. One thing you could do if you wanted to is like, let's say that's x, right? And then I could say like, x, ax is equal to x, the first or the second element, right? And that would basically pull out that second element from that x tuple. Okay, does that make sense? Cool, all right. And that's a very common Python thing that you'll see, not just in histogram, but in a lot of different places. All right, cool. So let's hear another question. We passed the parameter DDOF, that's degrees of freedom, right? To equals 1, np.standard. to make sure we correctly compute the standard deviation of the sample. What does this do? Yes, DDDOF. So this is something I think we can go a little more detail into, but basically part of the thing is like when you actually create the standard deviation, you need to know how many degrees of freedom you're using. And if I remember this right, oh my gosh, I always forget this. It's not just degrees of freedom, which is usually DOF, it's something degrees of freedom. And what's happening there is basically you're making sure you count the right proper number of things. And one of the things that can happen is when we do the standard error versus standard deviation, you'll see in some equations, you'll get some like square root like of n, but then sometimes it's the square root of n minus 1. And the reason why is because when we're doing a standard deviation or a variation of standard deviation, standard error is a variation of standard deviation, just we try to call it different things, which honestly causes more confusion sometimes. But the real reason why this happens is basically it's because we're already using a degree of freedom, like we're choosing one thing and solidifying this. This is me going really quickly over this stuff. But basically it's like we're freezing one part. And so we actually specify, hey, you have to actually consider that 1 degree of freedom. So instead of having n things, we have n minus 1. And that's what this is encompassing in that function. We can definitely talk more about this too, because I think this is honestly something that can confuse a lot of different people. But we'll check this out later. Okay. That's me kind of hand waving saying, don't worry about it right now. So last question related to the above question, should we use standard DX or DDF? Kind of same thing, is that if you're looking for that n minus 1 because you're using a sample, that's when you have to consider it. So maybe this is something we can talk about in the future too, like when we talk about t-distributions, because that's when you start to worry about like, oh, am I using a sample versus a population? They're slightly different from each other, though they look very similar. I remember back in like one of my physics professors said like this was like I think what was it, 2012 election, I think that's what it was, and we were talking about like the election, like margin of error and stuff like this, and he said the real thing, like this is a particle physicist, so they do a lot of statistics, and one of the things he's saying said the reason why or what separates a good statistician from a bad statistician is this guy right here, basically that n minus 1 part. And he said like Nate Silver, like I don't know if you guys are familiar with Nate Silver, 538.com and stuff like that, big statistician. He's like, Nate Silver, he knows what this is. Like basically it's that little subtleties that don't seem to really matter, but in the long runs of statistics, like having those subtleties, understanding that part. And honestly, a lot of times, most people don't, because honestly, you can just like, oh, just follow the equations. All right, great questions though. Cool. So I know I kind of went through, especially these past two really quickly and kind of like say, don't worry about it. But is there any specific questions that I kind of mentioned on here you guys have? Pretty good. All right, cool.